Don't believe the rumors. Writing tests for CSS is possible. A little bit about me. I've been developing since I was born, basically, probably till the day I die. I tried the whole managerial thing in startups and decided that I prefer writing code. Testing the code, I know it's weird, is a passion of mine. I love doing it. I love talking about it. And it's also now part of my work because I work at Applitools. I'm a developer advocate and a software developer, mostly software developer at Applitools, and we specialize in visual testing tools. Okay, I want to talk about fear today. What fear? Fear of standing before you. Given that all the previous talks were really, really awesome, I don't believe I said that. No, I'm going to talk about another kind of fear. But first, before we talk about that fear, I want to talk about web developers. We're in a front-end conference, but there are back-end developers that without them you would not really write significant applications. And they talk about things like thread pools and message queues and Scala. And there's the front. Now we like to say back-end developers and front-end developers. I want to split that. Front-end JavaScript developers, they're the magicians that deal with state and reactive stuff and event handling and things. They talk about JavaScript and Angular and DOM and all those weird things. But there's another kind of developer. It's the front-end CSS developer. They are beautiful. And they create beautiful things, and they talk about responsive design and media queries and Flexbox. And a wonderful thing, now that we've sorted out the clans, and I know everyone is a little bit of all of these, okay? But now that we've sorted out the clans, I want to talk about something else. Something wonderful is happening in the web world. Developers are starting to write tests. I've been doing it since, I know, this is weird. I've been doing it since 2000, something like that, where I founded my own company so I could do whatever the hell I wanted. And now, like 5-7 years, developers are really starting to write their own tests. And why are developers writing tests at all? I've invented a term. It's called ego-programmophobia. What is ego-programmophobia? It is fear of one's own code. Yeah. It's true. We don't talk about it a lot, but we really, really, really fear coding. A manager says, look, I just add this feature, and the way they think about it is like, Lego, right? You just pop in the new code, and you're done. Usually it's more like this. Yeah, we know, well, not always, but sometimes. That's one fear of adding code. Removing code, the manager, you look at a code, and it's like, I can remove that if. I can remove that CSS rule. It's so easy. Nothing will happen, right? Precision, surgical removal. That's the theory. In practice, sometimes things like this happen when we remove code. That is ego-programmophobia, people. Sorry, I had to finish. You had to. Thank you. And the last is fear of refactoring. The picture speaks for itself. Yeah. We do not refactor. We are afraid. We are afraid of our own code, people. And the more you understand that, the more you understand and believe it, the more you can cure yourself of ego-programmophobia. And it doesn't really matter whether our code is a horrible pile of spaghetti or beautifully crafted set of, loosely coupled small modules like I like it. We all fear changing that code. Because changing the code may mean breaking the app, and we don't like to break the app. And what happens when we change the code? We have to test it, and we have to manually test it, and we have to go through all the pages of the app and try out all the things, because who knows what we changed. But, as I said, a wonderful thing has happened. Web developers have discovered that testing or developer testing or developer automated testing, there's a lot of terms around it, removes the need for manual testing after code changes. And what is developer testing? It's a developer writing code that tests the code that that developer wrote. It's a bit like this, but we're writing code that tests the other code that we're writing. That is developer testing, and it is not QA automation engineers writing tests. That's okay. If you have that, that's fine. But I'm talking specifically about developers writing tests for the code that they write. Explicitly, developers owning their own tests. And tests, and that is the most important thing, abolish ego programmophobia. Tests abolish the fear of changing our own code. How? Well, you code, and you write the test for that code. Some people do it TDD style before. I don't. I write after. But it doesn't matter. It's during writing the code. And you run the tests, and they explode, obviously, and they don't work, and you fix, and they explode, until finally it works. And that is what testing is all about, because you can run the tests again and again. As I said, testing abolishes fear of changing our own code. Who's writing tests? Who's abolishing their fear? Oh yeah, actually that wasn't the question, but hey, who's writing tests? Come on, woo! Thank you, good. As I said, a wonderful thing is happening in the web world. But I want to go back to the clans. Backend developers have started writing tests for quite some time, I have to admit. They've been doing it, the methodology is, the tooling is basically there, okay? Front-end developers, testing is a young discipline for front-end developers. It's not totally there yet, there's lots of confusion, the tooling is like starting to become there, but it is happening this week, and we have these educators to help. We have Kent Dodds, the wonderful Kent Dodds, we have Justin Searles, Kevin Lamping, Gleb Barmutov, Shai Resnick, yours truly maybe, and others that are helping us create a common methodology. I like to say it as this: we're building a methodology based on unit testing, component and multi-component testing using JS DOM, and browser automation testing tools like Cypress and WebDriver.io. What about front-end CSS developers? They're sad. They don't know how to write tests for CSS. We don't know how to write tests for CSS. Why? Well, front-end JavaScript tests are functional. Think of a unit test, a good unit test, where the algorithm is stateless. You put in input, it runs the algorithm, you check whether the output is the one that you assumed would come out of it. That's functional testing. Now, unit testing, when you're just testing an algorithm or a part of business logic, that's what you do. You just, throw input at a function, look at the result, and you're done. But front-end developers, JavaScript developers, need a bit more, because they need to do also browser automation. They need to test whether their code functions in a browser. And it doesn't matter whether it's a real browser, like Chrome and Firefox, or whether it's a simulated browser using techniques like JS DOM. What they do is they run the application, click, click, click on all the buttons or whatever they need to do to activate the whatever they want, and then check the results. So you click on the button and check, that the counter is +1. Click on the button, check that the counter is +1. Click on the reset button, check that the counter is 0. That's basically how front-end JavaScript testing is done. You just look at the elements, write the code that automates the browser, look at the elements and check that what you thought should be is actually there. But how do I functionally test this thing? This is a test bookstore that we a lot of time use for our. How do I visually test this? Can I functionally test that this looks okay? That this looks how it should? I can't. Oh no, sorry. No. And I can hear the cries of anguish of CSS developers. We can't do functional testing, and it has been tried. I've seen people do this. You automate the browser, and it has to be a browser. You can't do it in JS-DOM because JS-DOM doesn't care about styling and layout. So you click on this and click on that, and then you want to check the CSS, so you start checking this element is strike through, and this element is positioned here, and this element is hidden, and this element is visible. And you can have hundreds of pages, and you still don't know whether it's correct or not. You're trying to do visual testing, CSS testing, in a functional way. Doesn't work. Well, a bit. You can't. You can't do functional tests and test CSS that way. Testing CSS is a really, really hard problem. It's machine learning hard, and we'll see later why. And the most important reason is because it's visual, not functional. Functional, we know how to deal with it. It's numbers, it's strings, it's elements, it's binary, all easy. Visual, all we get is a screenshot. All we get is what we see on the page. How do we check that? I mean, as humans, easy, not a problem. We look at the page and we know if there's a problem or not. We know whether a page looks good or not. And even then, we miss stuff. There are a lot of pages, if you know the gorilla page, where there's all these basketball players and you're supposed to count the number of throws they're doing, and there's a gorilla going through them. And because people are so intent on looking at the throws and tosses, they totally miss the gorilla. It's usually something that's shown, but I'm not. Even small movements like, 10 pixels to the right, 10 pixels to the left, people miss that. You can't, especially not day after day after day after day. This is something that a computer should do, and yet a computer has difficulty doing it. But don't believe the rumors. Writing tests for CSS is possible. How? When I talk to people about visual testing at conferences or at booths, they think something like this. You navigate, you use your browser automation tools, Cypress or WebDriver IO or Selenium or whatever. You navigate a page, take a screenshot, and then the visual testing tool verifies that it looks good. And I look at them and, what? Or maybe better. People are better. They think that visual testing tools verify that the UI conforms to a certain design system. So the design system says this is the margin, this is the color, these are the fonts, and the visual testing tool conforms to that. Unfortunately, our machine learning algorithms, because you really, really need AI here, are not that good. We don't know how to look at a page and say, it's good. We don't know how to look at a page and say, it conforms to the design spec. Our algorithms, our best people on it, they still don't do it yet. Who knows? But by then, it'll be too late. So how do we do visual testing? We don't check that everything looks good. We actually do visual regression testing. That's the formal name for visual testing, but it's too long for me. How does visual regression testing work? This is Cypress, and I'm using a plugin for Cypress called Image Snapshot something. It's based on Jest Image Snapshot, if some of you are doing visual testing using that. So that's based on that. Open source, as is Cypress. Side.viewport, I want to make it a certain size because responsive design, it could be looking totally different in another design. I visit whatever application I have. I run it previously. I do some typing and clicking and whatever actions I need to get the page that I want to visually test. And I test. Side.match image snapshot. But what is happening there? What is happening? And the magic is this. That single line, okay, that is what is happening behind. The tool takes a screenshot of your app, full page window. We'll talk about that in a second. It compares the screenshot. That's why it's called visual regression testing. It compares the screenshot to a previous test screenshot. We call it a baseline. But the first time, what happens the first time the test is run? Easy. That's the baseline. So the first time the test is run, you have to manually check all the screenshots to verify that they're okay. Otherwise, you're going to be comparing to bad input. That's not a good idea. So it will compare the two screenshots with a baseline screenshot, check for differences. If there are no diffs, good. The test succeeded. We're good. All our CSS is perfect. But if there is a difference, it can be because of two things, two reasons. What are the reasons? One, well, the obvious. It's a bug. My CSS or HTML is wrong. I deleted a line, a rule that I shouldn't have, or whatever. Or if it's not a bug, what is it? It's a feature. I added a button. The computer, the algorithm, the image algorithm can't say whether it's a bug or a feature. You need a human to verify whether it's that or that. If it's a bug, good, the test failed and we're good. We found a bug in CSS, we're perfect. If it succeeded, if it's a feature, what we do is we update the baseline. This is the new image to compare against. That is what visual regression testing does, and that is all inside that line. Okay? That's what a visual testing tool does. So that's how you test your CSS. Thank you very much. Questions? Nah, I'm joking. There's an elephant in the room. Not here. Maybe. People who do CSS testing, people who do visual testing, know about it, but they don't talk about it too much. There are actually 4 elephants in the room that are not being talked about it. Because if it was that easy, a lot of people would be doing it. And I remember my time, I used to work at Wix, and we had this Greenfield project. And I really wanted to do it right. It was my first front-end project. I wanted to do front-end right, test everything. And we really tested everything, JS DOM and browser automation and everything. It was really, really cool. And then I said, oh, hey, what about the CSS? What about how it looks? And I tried. And I tried doing this. And I basically failed because of the 4 elephants in the room. Elephant number 1. That's weird. Taking a screenshot, that surprised me, is hard. I mean, first of all, there are 4 kinds of screenshots that you want. One is full page. You want to see the whole thing, even things under the fold. The other is viewport or window. You want to see what's above the fold. That's a screenshot that you want to take sometimes. And the third one is selector. You just want a component, not the whole thing. You just want a subset. Or you just want an XY with height, but that's rarely used. If you're using Cypress, they have it. Chrome is really, really good at generating screenshots, and Cypress runs Chrome. But if you want cross-browser, if you want Firefox, Safari, others, you have to use Selenium WebDriver or others, WebDriver IO. And that only supports viewport. No full page, no selector, no region. So what do? Do we abandon ship and say, hey, CSS testing is hard, I'll keep being sad in the rain? No, don't believe the rumors. Writing tests for CSS is possible. Taking a screenshot is possible. If you want, if you want Chrome only, I know a lot of people don't like that. Use Cypress or Puppeteer. It works. No need. It has all the options. But if you want to use Selenium WebDriver, WebDriver IO, all those that are based on that, you need to use one of the commercial tools. They have SDKs that enable you. They do all these kinds of weird scrolling tricks to grab the full page and do that. Elephant number 2. That's a big one. That was why I failed doing CSS testing at Wix. You have your baseline screenshot. You have your current screenshot. How do you compare them? Pixel by pixel is the only way I know how to compare. But, and that's a big but, see these These were taken on my Windows machine, and this was taken on my friend's Windows machine. They look entirely alike, but let's look on the two. It's the graphics driver. It's the same version of whatever browser. I don't remember what it is. It's the same Windows version, everything. It's the graphics driver that is making this difference. So pixel by pixel, we'll see how they solve that. Here's another one. This is the same JPEG in Chrome 67 or 68. Same nice doggy, right? Let's diff it. I don't know what they did. We were surprised too, but the whole pixels have changed. I'm assuming it's because it's a JPEG, so rendering JPEGs is different. So yeah, even different browsers, same browser, same everything, but different versions, you get diffs. And remember our testing bookstore? I was surprised at that. I used the open source tool. This is one, and this is the other. As you can see, they're exactly the same. But if I diff it using that, there are small differences. This was taken on same machine, on same version, like 2 minutes separate from another. I immediately grabbed the screenshots because I didn't believe it myself. Which is why we have this. These things take, all of these tools take configs, which define the percentage of error. It can be defined in lots of ways. That's why there's a lot of text here. It doesn't really matter, but you're basically moving a slider. And that slider is basically how many false positives do you want versus how many false negatives. Okay? If you say, I don't care about 100% of the errors, then you'll always be good. If you say 0%, you will get false positives. So it's a slider playing that, and you can configure it on each and every screenshot because each and every screenshot is different. But it is a solution, and it works for a lot of people, and a lot of good people that I know. So, do we move that slider around or maybe abandon ship? Nope, don't believe the rumors. As I said, writing tests is possible. Some of the tools employ advanced screenshot comparison algorithms. Some tools don't, okay? It depends. And they see as a human would see. They take the page and not compare screenshots. They look, they find the images, they find the text, and they do lots of very advanced visual comparisons to ensure that there are no, or almost no, false positives or false negatives. And they all of them have free and OSS plans. Come talk to me later if you want the details. Elephant number 3. Managing the comparisons is hard. Remember, you take a screenshot, compare the screenshot with a baseline. The 3 steps are done automatically. The 4th step is something that you do as a human manually when your test fails. And we have to do that for hundreds of comparisons. And that's difficult. Do we abandon ship? Nope. There are 3 ways to deal with that problem. One is, and usually it works, it's the same bug everywhere. So I just accept all the baselines from all the hundreds of screenshots, hoping that there's not another bug injected in there somewhere in one of the other screenshots. That's one way of doing that. The other is you have a folder with baseline and actual images, and whenever you want to accept an image, you just drag it from one folder to another. That's another way of dealing with screenshot comparisons. The third is obviously commercial and OSS tools have GUIs that enable you to check the things in a slightly better and GUI-wise way, because we are talking about visual testing. Elephant number 4, and the last one, testing all those responsive widths and browsers. That's a huge problem. Think of that. We're all doing responsive design today. Who's doing responsive design? As I said. And we need to check our page in 1024 by 768 in Retina, in iPad, iPhone, even in IE. Some of our customers have to check that in IE, Chrome, Firefox. It's not just responsive design, it's different browsers. How do we do that? How do we check all those options? Abandon ship? Nope. Don't believe the rumors. Writing tests is possible. Solution number one, we saw that test. What we do is we just run the test multiple times for multiple viewports. So it's pretty easy with Cypress, Mocha, whatever testing tool you're using. You just for each the test, and for each of one of those devices and sizes, and you just side-dot viewport your way to different responsive designs. But it does mean that you have to run your tests again and again in a serial fashion. Another option, this is the easiest and it's great. Another option is if you have hundreds of tests, and sometimes you do, parallelize it. Run this test on Firefox, this test on Chrome, on this width, on that width, etc., etc. Run all your visual tests, run them in parallel, and voila, we have tests for all the browsers and all the viewport sizes that we want. That's another option, a bit more difficult, but definitely possible. Solution number three is letting the cloud do it for you. Some vendors enable you to take not a screenshot, but rather what we call a DOM snapshot. It takes the whole page, HTML, CSS, images, SVGs, fonts, etc., uploads it to the cloud, and there's a grid of browsers waiting to render that screenshot in different widths and different browsers. So that's solution number three, letting the cloud solve it for you. So, it really is as easy as this. I mean, writing the test really is easy. You should be doing that. Take that step. Take that first step. Start writing tests for your CSS. Abandon the fear of your own code. Start curing your ego programmophobia. As long as you take care of these four elephants, because otherwise you may start well, but in the end it will come to bite you. And in summary, as I said, don't believe the rumors. Writing tests for CSS is possible. Join the backend and the JavaScript clans of web development. You can cure your CSS ego programmophobia. It's a hard problem, I'm sorry to say, because it's a visual problem. Taking screenshots, managing those screenshots, comparing those screenshots, and testing across browsers and responsive widths is difficult. But it is solvable with both OSS and commercial tools. So, who knows the litany of fear? There's going to be a movie about it. Thank you. Oh, it's from Dune by Frank Herbert, and I will read it to you. I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. I will test my CSS. I will permit it to pass over and through me. And when it has gone past, I will turn the inner eye and see its path. Where the fear is gone, there will be nothing. Only my tests will remain. Thank you very much.